AI. You hear that term everywhere, right? But what does it actually mean? What does it do? Well, today we're going to pull back the curtain on artificial intelligence. We'll look at everything from the apps already on your phone to the big, complex systems that are literally building our future. So yeah, let's dive in. You know, it's easy to think AI is all about futuristic robots and sci-fi movies. But the truth is, it's already here and it's a massive part of your daily life. I mean, think about it. That second you unlock your phone with just a look, yep, that's AI. Asking Siri or Alexa for the weather forecast, that's AI too. And you know when Netflix just knows what movie you want to watch next? Or when Google Maps finds that magic shortcut to save you from a traffic jam? That is all artificial intelligence just humming along quietly in the background. Okay, so how are we going to unpack all of this? Here's our game plan. First, we're going to stick with what you know, the AI that's literally in your pocket. Then, we'll get into the real engine behind it all, how machines learn from data. From there, we'll take a quick tour of the three main ways they do that learning. After that, we'll peek under the hood to see how an artificial brain is built. And to wrap it all up, we'll talk about the new kid on the block, the creative AI that's, well, it's changing just about everything. All right, let's kick things off with section 1, AI in your pocket. Before we dive into all the super complex stuff, let's just get on the same page. Let's start with a really simple, clear definition. When we throw around the term AI, what are we really talking about? So, at its absolute core, artificial intelligence is, well, it's pretty much exactly what it sounds like. It's all about building technology that lets computers do things that usually need a human brain. Simple as that. We're talking about simulating our own intelligence, our ability to think, to reason, to learn, but inside a machine. Okay, but what does human intelligence actually look like when a machine is doing it? Well, it's stuff you see all the time. It's about recognizing patterns, like how your phone's photo app can magically find every single picture of your dog. Or it's about understanding speech, which is exactly what Siri or Alexa are doing. It could even be analyzing an image, like a traffic camera reading a license plate. All these things are just mimicking the skills that we humans use every day. Okay, on to section 2, learning from data. Now we're getting to the real heart of modern AI. The absolute game changer, the breakthrough that made all this stuff possible, is a field called machine learning. Seriously, you can think of it as the powerful engine that runs pretty much every single AI app you touch today. The best way to picture this is with a set of those Russian nesting dolls. You know the ones. So artificial intelligence is the biggest outermost stall. That's the whole field. You open it up, and inside you find the next stall, machine learning. Open that one, and you've got an even smaller one called deep learning. And right there in the very, very center, the smallest stall, is the newest member of the family, generative AI. It's a cool way to see how they all fit together. But for right now, let's just focus on that second doll, that crucial layer, machine learning. Okay, this slide right here, this is the big aha moment. This is the fundamental shift that makes modern AI so incredibly powerful. See, with traditional programming, a human, a coder, has to write out every single rule. You give the computer some data, you tell it the exact logic to follow step by step, and it spits out an answer. But machine learning, it flips that script completely. Instead, you give the machine tons of examples. You give it the input and the correct output, and it works backward to figure out the logic all by itself. It literally learns the rules from the data. That's the magic trick. So this whole learning thing basically happens in 2 steps. Let's make it real with an example, say a bank trying to approve loans. Step 1 is training. The AI model gets fed thousands and thousands of old loan applications. That's the input. And it also gets told whether each one was approved or rejected. That's the output. By churning through all that data, it starts to see the patterns, what makes a good applicant. Then comes step 2, inference. Now, when a new person applies for a loan, the AI uses all the patterns it learned to make a prediction, yes or no. That's the essence of it, really, learning from the past to make smart decisions about the future. All right, so we've established that machines learn from data, but how exactly? Turns out there are 3 main ways they do it. Let's go on a quick tour of each one. First on our list is something called supervised learning. The best way to think about this is like studying for a big test, but you've been given the answer key ahead of time. The machine gets a huge data set where every single piece of information is neatly labeled with the correct answer. It basically has a teacher looking over its shoulder, showing it what's right and what's wrong, over and over again. And you see this every single day. Your email spam filter, that's a perfect real-world example. It was trained on millions, probably billions, of emails that people like you and me had already marked as either spam or not spam. By sifting through all of that labeled data, it learned the patterns of what junk mail looks like, all on its own. Okay, next up we have unsupervised learning. And as you can probably guess, it's pretty much the exact opposite. This time, the machine is just handed a giant, messy pile of data. There are no labels, there's no answer key. Its job is to just dive in and try to find its own hidden patterns and structures. It's like learning completely on its own, with no teacher. A really great example of this in action is how news sites group articles. An AI can scan through thousands of articles from a single day and start grouping them together. It'll figure out, hey, all these articles are talking about similar things, and it'll create a cluster for sports, another for politics, and another for tech. And the crazy part is, no one ever told it those categories even existed. It just found the patterns and sorted them out. And that brings us to our third type, reinforcement learning. This one is all about learning from trial and error, just like we do. Imagine an AI, we'll call it an agent, trying to accomplish a goal. It takes an action. If that action gets it closer to the goal, boom, it gets a reward, a little digital pat on the back. If the action is bad, it gets a penalty. And over millions of tries, its only mission in life becomes figuring out the strategy that gets it the absolute most rewards. Honestly, it's just like training a dog. Good boy, you get a treat. Bad boy, no treat. It's the same idea for an AI learning to play a game like chess. If it makes a move that captures an opponent's piece, it might get a few reward points. But if it makes a move that leads to checkmate, it gets a massive reward. And after playing millions and millions of games, it learns the best possible strategies, all driven by this simple hunt for rewards. All right, Section 4, building an artificial brain. We're going one level deeper into our nesting doll now, into the world of deep learning. And this is all powered by an amazing concept called a neural network. And what's that? Well, it's basically scientists' and engineers' attempt to build a simplified model of a human brain, but using code. To get our heads around this, let's use a super simple analogy that we've all been through, calculating a final grade in a class. You've got different inputs, right? Your midterm score, your final exam score, maybe a few quiz scores. But they're not all worth the same. The final exam has a much bigger weight or importance than a pop quiz. You combine all those inputs, factoring in their different weights to get your final grade, the output. Believe it or not, a neural network learns in almost the exact same way. Data goes in, and every piece of that data is given a weight, a number that represents how important it is, just like the final exam was worth more. The network then takes a guess at the right answer. Now, if that guess is wrong, it does something brilliant. It goes back and slightly adjusts all of those weights to try and do better next time. And it does this over and over and over, millions of times, constantly tweaking those weights until its guesses get super, super accurate. It's literally learning which pieces of information are the most important. And all of that brings us to the very center of our nesting doll, the one everyone is talking about, the technology that's been all over the news lately, generative AI. So what's the big deal? What makes generative AI so special? Well, up until now, the AI we've talked about has been about predicting things or sorting data that already exists. But Gen AI, it creates. It doesn't just analyze, it generates brand new, totally original content that has never existed before. We're talking text, images, music, even video. I mean, just look at this example. The prompt was simple. Write a one-sentence story about a robot who discovers music. And the output, it's not just a factual answer. It's creative, it has style, it has imagery, it has feeling. This ability to create something new from a simple idea, that's what makes generative AI such a mind-blowing revolution. Wow, okay, so we've taken quite a journey, haven't we? We've gone from the simple AI in our pockets all the way to these incredibly complex models that can write stories and create art. So let's take a step back, put it all together, and think for a second about what this all means for the future. Think about it. We have now built machines that can learn, that can predict, and can even create. This is a huge deal, and it means the conversation is shifting. The biggest question isn't really about how the technology works anymore. The real question, the one we all have to think about, is how we're going to work with it. That's the challenge and the opportunity that lies ahead.